Right now, at 3 a.m. inside the Smolensk aviation plant, Russian technicians are working overtime. They are carefully assembling the guidance seekers for the Kh-59 cruise missile, the weapon of choice for the Tu-95 bombers terrorizing Ukraine. They feel safe, deep inside Russia, protected by layers of Pantsir and Tor batteries. They have absolutely no idea that a swarm of Liutyi drones has been airborne for hours and is currently checking its watch. The math behind this strike is humiliating for the Kremlin. Each of these drones costs roughly $200,000. The target they are hunting is the Kh-59 cruise missile, which costs Russia nearly $1 million a pop. Tonight, Ukraine intends to vaporize the entire assembly line that builds them. 04:45 a.m. The mixed formation of 20 drones, 12 lethal AN-196 Liutyi strike units, and 8 smaller Rubica decoys crosses the Dnepr River, pushing deeper into Russian territory. They are flying using a terrain-following profile, hugging the landscape at under 1,000 feet. The onboard AI machine vision systems are scanning the forests and hills below, matching the physical geography to pre-loaded 3D maps and adjusting the flight path in real time. To a ground observer, they are invisible. To a standard radar, they are hidden in the noise of the Earth itself. Back in the command bunker, the Ukrainian operator stares at his monitors. Sweat begins to bead on his forehead. The mission plan relies on over 1,000 pre-programmed waypoints designed to zigzag unpredictably, but battlefields change faster than code. Suddenly, a secure notification flashes on the communications screen. It's an urgent intel packet from the deep cover agent inside Smolensk, a Russian factory worker secretly loyal to Kyiv. The message was sent via an encrypted app over a Starlink connection and contains a single grainy photo and a set of coordinates. Mobile air defense relocation, the operator mutters, his fingers flying across the keyboard. The intel is critical. A Russian Pantsir S-1 mobile unit has just deployed into a field 5 miles south of the aviation plant, directly blocking the swarm's primary approach vector. This unit wasn't on the satellite imagery taken 6 hours ago. Without this human intelligence, the entire swarm would have flown straight into a wall of 30mm cannon fire. The operator executes a rapid command override. He uploads a new flight path to the fleet. The 12 heavy Liutyi drones bank hard to the west, dropping even lower to mask their approach behind a ridgeline. Meanwhile, the 8 Rubica decoys are commanded to maintain their altitude and original heading. They are the sacrificial lambs, designed to fly high and loud, mimicking the radar profile of cruise missiles to draw the eye of the Russian gunners while the real killers slip through the shadows. The combination of high-tech drone autonomy and old-school spycraft has just saved the mission. 5:30 a.m., 50 miles from the objective, the trap is sprung. The helmet radar of the lead Pantsir S-1 battery lights up, instantly locking onto the high-altitude signatures of the Rubica decoys. The response is violent and immediate. The mobile air defense unit unleashes a volley of 12 57E6 two-stage interceptors. Accelerating to Mach 4 in seconds, the missiles tear through the pre-dawn sky. In less than 20 seconds, 6 of the decoys are obliterated, turning into expanding clouds of fiberglass shards and black smoke. A mile down the road, a Tor M2 battery joins the turkey shoot, launching its vertical launch 9M331 missiles to swat the remaining 2 decoys out of the air. Inside the Russian command vehicle, the radio crackles with arrogant satisfaction. "All targets splashed," the battery commander reports, leaning back in his seat. "We wiped them out." They believe the attack has been broken. They are confident in their new tactics, which rely on mobile fire teams and rapid reload drills to counter drone swarms. But hundreds of miles away, the Ukrainian operator watches the telemetry and permits himself a cold smirk. "They are shooting at clouds," he whispers. While the Russians high-five over the destruction of the bait, the 12 AN-196 Liutyi strike drones are untouched. They are flying well below the radar horizon, hugging the contours of the Earth so tightly that the Russian radar beams pass harmlessly over them. The onboard machine vision cameras read the tree line and riverbanks, making micro-adjustments to keep the formation hidden in the ground clutter. The Russians just emptied their ready racks on flying lawnmowers, completely unaware that the real sledgehammer is swinging at them from the darkness below. 05:55 a.m. The stealth game ends abruptly at the 20-mile marker. The surviving Liutyi drones push into the inner defensive ring, and the Russian air defense grid finally gets a clean lock. The primary Pantsir S-1 battery opens fire, its cannons tearing through the pre-dawn gloom. 4 of the strike drones are shredded instantly, their fiberglass bodies disintegrating. But the cloud of debris creates a new problem for the Russians: radar clutter. The scope is now filled with thousands of falling fragments, masking the approach of the remaining units. Then, the electronic environment goes toxic. The Russians activate a Krasuka 4 broadband jammer, flooding the spectrum with high-intensity noise. Combined with heavy crosswinds, the satellite links begin to fail. But just as the jamming threatens to blind the attack, the Ukrainian intelligence network plays its ace. Deep inside the facility perimeter, the embedded agent risks everything. Hiding in the shadows of a warehouse, he snaps a photo of the main Pantsir unit, which has just exhausted its ammunition and is lowering its stabilizers to reload. He sends the image and coordinates via a compressed burst transmission. The Ukrainian operator receives the packet instantly. It is the golden ticket. He highlights 4 of the reserve Liutyi drones and designates the reloading air defense system as the primary target. "Saturation dive," he commands. The 4 drones bank hard, ignoring the factory to dive directly onto the Pantsir. The Russian crew, caught with their missile tubes open and cannons dry, can only watch. The impacts are simultaneous. A $15 million system vanishes in a fireball before the crew can even load a fresh clip. The Russians fight back with desperation. A Yak-52 prop plane modified for interception scrambles to hunt the slow-moving drones, while Russian net hunter drones join the fray. They manage to knock 2 more Liutyi out of the sky. But the defense is crumbling. The Pantsir is burning. The Tor battery is stuck in a 5-minute reload cycle, and the agent on the ground sends a final text. "Pantsir down, ammo depot exposed." With the jamming still screaming, the operator flips the final switch. The remaining drones disengage from satellite control and activate autonomous mode. They are no longer listening to radio signals. They are flying purely by machine vision, matching the terrain features to their internal database. They are now immune to jamming, immune to fear, and locked onto the assembly line. 05:58 a.m. The clock hits the 2-minute warning. Through the electro-optical nose camera of the lead Liutyi drone, the target resolves from a blurry shape into a high-definition reality. The main assembly hall of the Smolensk aviation plant is blazing with light. Inside those walls, Russian technicians are working a frantic night shift, fitting delicate television and infrared seekers onto the noses of Kh-59 cruise missiles destined for the bomb bays of Tu-95 strategic bombers. They are building the weapons that will target Kiev next week. They have no idea that Kiev has just arrived at their doorstep. 90 seconds to impact, the defensive grid has collapsed. The primary Pantsir battery is a burning wreck from the saturation strike, its ammunition cooking off in bright flashes. The nearby Tor M2 battery fires a final desperate missile, but the guidance radar cannot lock onto the low-flying fiberglass bodies amidst the thermal clutter of the burning vehicles. The interceptor screams harmlessly into the forest, detonating against a pine tree. 60 seconds. The surviving Liutyi drones pitch over, converting their altitude into pure speed for the final run. The machine vision locks onto the geometry of the factory roof. In the Ukrainian bunker, the operator leans forward, his knuckles white. "Fierce payback," he whispers. Inside the Russian command center, the radar operator stares at a screen full of inbound vectors with 0 defensive assets left to stop them. His face drains of color. He keys the base-wide address system, his voice cracking with panic. "All defenses down! Vampire inbound! Evacuate the assembly line!" 30 seconds. The smoke from the burning air defense systems drifts across the flight path, momentarily obscuring the camera feed. But the autonomous AI doesn't blink. It predicts the trajectory and holds the line. On the ground, the agent Atesh bursts through the emergency exit of the warehouse, sprinting into the cold night air, putting as much concrete between himself and the building as possible. 10 seconds. The target is now filling the entire lens. The production line capable of churning out 200 cruise missiles a year and the stockpile of semi-finished turbojet engines are right in the crosshairs. The Russian military is about to watch $1 billion of air defense capability fail to stop a weapon that costs less than a luxury car, guided by the one thing they couldn't jam, the human element. The window for intervention has closed. Physics is now the only law that matters. 6 a.m. The first AN-196 Liutyi strikes the reinforced roof of the main assembly hall at a dive angle of 80 degrees. Traveling at terminal velocity, the 440-pound airframe acts like a kinetic spear. It doesn't crumple. It punches through the corrugated steel and concrete decking with terrifying ease. Inside the drone, the fuse timer activates. This is the crucial detail. It is set for a 0.05 second delay. It doesn't detonate on the roof, it detonates inside. The 165-pound high-explosive warhead triggers mid-air 20 feet above the factory floor. The blast wave, moving at supersonic speed, generates an immediate overpressure of 1,200 psi. It slams downward, crushing the delicate assembly rigs and the technicians standing next to them. But the explosion is just the match. The fuel is the target itself. The shock wave rips open the crates of solid rocket propellant used for the Kh-59 missiles. It shears the fuel lines of the semi-finished turbojet engines lining the racks. The air inside the factory instantly turns into a fuel-rich aerosol mixture. A millisecond later, the fireball catches up with the pressure wave. The temperature spikes to 3,000 degrees Celsius, hot enough to vaporize aluminum and warp structural steel like plastic. The remaining drones in the swarm follow the leader, diving into the hole created by the first blast or smashing through the skylights. They are piling explosives on top of explosives. As the sun rises over Smolensk, the full scale of the disaster becomes visible. The main assembly hall is a smoking ruin, its roof collapsed and its interior gutted by fire. Intelligence assessments estimate that 70% of the production capacity for the Kh-59 missile has been wiped out in a single morning. This isn't just a bad day for the factory manager, it is a catastrophe for the Russian Air Force. This facility produced between 120 and 140 cruise missiles annually. Those missiles are gone. The semi-finished units on the line? Gone. The specialized tooling required to build them? Melted. The ripple effects will be felt immediately on the front lines in Ukraine. The Tu-95 MS strategic bombers, the terror of the skies, have just had their supply chain severed. Without the Kh-59, Russian commanders will be forced to use the far more expensive Kh-101 cruise missiles for tactical strikes, weapons that cost twice as much and are in even shorter supply. The frequency of missile terror attacks on Ukrainian infrastructure is about to drop significantly. Economically, the blow is staggering. Ukraine traded a swarm of $200,000 drones for $500 million and destroyed Russian infrastructure and air defense systems. But the time cost is even higher. Due to Western sanctions on high-tech components, replacing the specialized machinery inside that factory will take at least 18 months.